We'll have our first keynote. Mr. Dr. Risto Tiainen from Visedo Oy is coming to give us a speech about power electronics for hybrid working machines, a real-world case in under 2-year payback time. So that sounds like trying to make business. Visedo is a startup company which was founded in 2010, and I'm proud to say that Visedo is almost totally occupied by Lut doctors. So, Risto, make the show and convince us that you can change the world. Here is the system for you.
Thank you, Juha, for the introduction, and hello, ladies and gentlemen. Yes, first of all, I would like to thank the conference team and conference organizers for giving Visedo this chance to give a little ideas or insight into what we find interesting or important in the field of power electronics. And first, a few words about the company perhaps are in order, because we are not a very big company or very well known. Some of you may not have heard of us. That picture that Mr. Tolvanen showed about ABB 125 years ago looked a bit more like us than ABB today. But anyway, we are a company that makes all sorts of power electronic devices as well as motors and generators, electric motors and generators, for these three segments, which are the heavy mobile work machines, marine vessels, and buses. And as the topic or title said, I'm today going to concentrate on the first of these segments. We are a company which sells not only the components, but we also sell systems that we design in cooperation with our customers. Electrification in all mobile devices, such as cars and so on, is increasing. And in the case of mobile work machines, the drivers are clear. The electric solution reduces often fuel costs compared to traditional ones. And at the same time, it either increases productivity or at least keeps it as good as it is. And these two factors combined result in making more money, to put it bluntly. And of course, also green values come as a side effect. We create less carbon dioxide emissions or small particle emissions and so on. But nonetheless, it's easy, or I'm not a salesman, of course, but it should be easy to sell this to companies. Practice might be different, of course, but anyway. And another driver is the new regulations which demand manufacturers of work machines to comply with stricter emission requirements, small particle emission requirements, and so on. Now, here are a couple of examples of electrified or hybridized mobile work machines to give a better idea what I am talking about. The first one here is an excavator which has a diesel engine, the red one here, which turns the electric generator, the green, which is controlled by an inverter, which transforms the electrical energy into DC. And in the DC link, which is this yellow part here, we have an energy storage device this blue box, which could be a supercapacitor, for example. And here is an actuator, an electric motor, which is again driven by another inverter, the bluish box there. So what this machine does, well, it's an excavator. It excavates stuff like this. And when it does only this, the electrical system doesn't have much to do. But when it accelerates and then decelerates like this to dump the earth someplace other, then there is potential for storing the kinetic energy and then again releasing it when accelerating again and decelerating. So here we have one key requirement for energy saving, which is usually cyclic operation. Another similar example is this wheel loader, which uses electricity to drive the wheels. There are 4 drive motors in the wheel hubs. And then there are again these same components, the diesel engine turning the generator and the supercap in the DC link. So here we accelerate and decelerate when we load stuff into the loader. Now, as this is a scientific conference, I thought that it would be fitting to include some points in different topics which we consider important or interesting in our field of application. Now, electric machines are relatively old technology, 100 years or more, but still development takes place and needs to take place because requirements are changing. And in mobile work machine segment, customers usually want the world's strongest man and the fastest man to be the same man. Namely, they want to have a lot of torque here in the low speed range while being able to run very fast deep into field weakening, or better still, run very fast without getting into field weakening. So demands are conflicting. New technology has emerged. Our current solution relies on permanent magnet machines with some reluctance torque also in them. New technologies might be suitable, switch reluctance machines, for example. Then, whatever the technology, we need to select the nominal point and the characteristic of the machine so that we find an acceptable compromise between these demands of speed and force. Cooling is something important in mobile machines. Air cooling is not usually very good. You have a lot of dirt and other obstacles in air cooling, and fans are easy to break if you have external fan motors, which is not, of course, usually the case in electric motors. But anyway, air cooling is not good. Well, liquid cooling is better. That liquid in our products is water or water glycol, but also oil cooling would be interesting in some cases. And this has been studied. Another requirement is to have the machine work efficiently in a wide set of operating points. And here is an example of our own machines and their efficiencies. So it's not enough to make a good machine in the nominal point. We want to run it in different points. Well, motors are one thing, or generators and motors, and then we need power electronics to control these motors. And drives or inverters pose some interesting questions to us. Well, motor control is also not a very new art, but still there remains things to be studied, especially if we develop new types of motors. And we need, of course, then good control to run them. Safety systems, DC link capacitance, sizing, efficiency. We need to have also in inverters very wide operating point set where we run in high efficiency. And we also would like to minimize the losses in the inverter to minimize the need for cooling. And then lifetime, the loads in mobile work machines are cyclic very often, and they need to be, if you want to save a lot of money. Then the requirements for semiconductor durability, lifetime, and performance with aging are high. And then also cooling here is a major thing. Transporting heat is not often as easy as it sounds. Now, energy storages are an important matter when we are dealing with mobile machines. There are a lot of technologies competing in batteries and also some in supercaps. We would, of course, hope to have new technologies that would increase the energy per volume or per mass, or preferably both. Lifetime is important here too, and cyclic loading again. And this kind of online performance analysis, so that we can say how much the characteristics of the energy storage have deteriorated since it left the factory. For example, supercapacitor series resistance and inductance. Because currents, especially in supercaps, are very high, and even a small series resistance creates a large voltage drop. Here are some comparisons of some unnamed technologies with cyclic loading in high temperature, 65 degrees. And the best is, of course, our solution. And now, I personally think that this systems part is the most interesting here. Component sizing is, of course, the first thing to, well, if not optimize, then at least make good enough. Pick the correct size for the diesel engine, for the generator, for the motors, and so on. And one particularly interesting thing is the management of the energy storage. Here are two pictures that illustrate this point. The green is the power of the actuator. These are, I think, from the stone crusher originally. The load fluctuates very rapidly. The blue one is the power of the diesel, which changes less quickly. It's kind of low-pass filtered. And the red one is the voltage of the supercap. In this system, we have the supercap directly in the DC link. And these two pictures are obtained with the same load data, but different tuning for the supercap voltage controller. And as you can see, the general form of the voltage is similar between these two cases. But in this left one, the voltage is allowed to drop a bit lower. Now, it's hard to say, or even impossible to say, which one in these two is better. If you let the voltage drop low, you are using your energy storage efficiently. The diesel will probably sound more civilized. It's running on lower speeds. But then again, you increase losses in your electric system, and you don't perhaps have the torque reserve needed for some high load peak. So if somebody would tell us what's the optimal way to control the energy storage voltage or capacity level, we would be very happy. Well, system problems don't end here. Sometimes it would be interesting to see comparisons between series hybrid and parallel hybrid. Energy flow management, the control principle, who controls the voltage? Is the voltage controlled? Do you calculate powers, or what do you do? That's something interesting. The next point is a question: should the DC link voltage be the same as the energy storage voltage? This translates to a question whether we should have a DC-DC converter in between. This would eliminate the excess losses caused by low DC link voltage and allow the electric system to run with better efficiency. But then again, DC-DC converter with sufficient current handling capability is not cheap. So would it be economically feasible to use one? Safety in systems. What do you do if an inverter trips? How do you brake then, and so on? Grid connection. It could be used in some cases when you park the machine somewhere to do the work. Then you could plug in and take some energy from the network instead, which is usually cheaper than buying diesel. So all in all, it would be a matter of finding the best, or actually even good enough system for a given application with the limitations posed by the application taken into account. Now for the actual beef of the show, which was to crush, literally or less literally, the fuel consumption. And the example is a stone crusher from an Austrian company called Corman Rockster Recycler. And it's not a particularly big stone crusher, but still quite awesome machine. And it's used to recycle material. In this picture, you see that there are some concrete slabs and sand and stones here. These are probably the remains of a house demolished. And this picture was taken in the Rockster test field in Austria. Here are some of our inverters in the actual working environment. They are not protected by any enclosing other than their own. Here in the lower part we have the supercap, which luxuriously has a piece of metal to hold it there, but no external shielding or anything. There's the diesel that runs the machine, and generator is not very clearly visible, but it's there. So it's a series hybrid machine where we generate electricity from diesel into DC and then consume it in the crusher motor. So no mechanical connection between the diesel and the crusher. Here is an unnecessary complex figure of the same thing. I just left it as it is to show that there are a lot of little pieces other than the ones mentioned. And here's also shown a network connection option which was not implemented in this first prototype or first machine. Here are some measurements from an end customer. The machine was completed a little more than a year ago and delivered to a customer in France who have used it since. And these measurements show that we have succeeded in making an electric system which runs at relatively high total efficiency at all operating points. Here when it is loaded, and also here when it's practically idling. And here are some figures relating to what makes this machine economically feasible. Well, we did save the fuel as we promised. Here it says that this is 30% less. Yeah, that's probably rather accurate. But in the same time, we also increased the output of the machine. The electric motor is capable of crushing with higher torque than the previous solution, which was a hydraulic one. Now, cost per ton is significantly lower. I'm not quite sure if these figures calculate, but the key idea is still correct. Both increase in production and decrease in fuel consumption. And this gives us payback time of 6 to 8 to 9 months, depending on how you think the interest rates are. And as the lifetime of this machine is significantly higher than half a year or 3/4 of a year, this means that it's very economically feasible. And the customer has been happy, quoted as saying that this machine is not from this world, and now I can make some money. But if I was an operator or owner of this kind of machine, I wouldn't buy this traditional thing after seeing how well it works. Now, I think we also have a little video here to give you a better practical idea how the stones are crushed. This is also from Rockstar test field and not from the end customer. Yeah, it's much faster than a man and a sledgehammer. Oh, okay, thank you everybody. Shall I stay here to answer some questions?
Yes. Do we find questions immediately from the audience, or shall I put the first one? Actually, I don't see if there is somebody who's... The microphone, please.
I think I can do without. First
Yeah.
question would be, can you make this presentation available?
Yes, I think I can. If it's not already available, I'm not sure.
Thank you.
Okay. More questions from the audience? Another question, please.
Okay. I could hear you very well. I don't know about
Okay,
the
but
audience.
maybe the audience has difficulties. So, very interesting, thanks. You hinted out that lifetime of power electronics is one of the issues, and you also stated that the machine has to last longer than those 8 months of payback time. I assume you calculate 15 to maybe 20 years of operation?
Well, I don't know very well this particular case, how long they plan to use them. I don't know if it's 20 years. So in this case, probably the power electronics will not be an issue, or their lifetime will not be an issue.
No, surprise. It's not. Well, that's new, because usually in those heavy work machines, the power electronics is stressed very heavily, and there come special requirements towards the power electronic in use. But I think that's something we can discuss at your booth.
Yeah, well, there might be cases where the situation is different, but I haven't calculated the number of cycles. It may very well be that it is an issue. Our components use power modules which have sintering technology in them, so they don't have the bonding wires. They are not as easily damaged or worn out as conventional types.
Okay, thanks.
Okay, the next question is there.
Sarat Tenekun from Staffordshire University. Do you actually provide complete machines, or do you retrofit existing mechanical diggers, so to speak?
Sorry, I couldn't quite...
Yeah, sorry. Do you supply complete machines, complete equipment, or do you supply only the power electronics?
No, we don't sell any complete machines, but we do sell complete systems. Like in this case, there was our generator, inverter, supercap, energy storage, motor inverter, and motor. And we did a custom application to ramp up the machine smoothly with pre-charging and sequences for emergency stop when you need to stop the drum as quickly as possible, and so on. So we do also application development and complete system design.
Okay, thank you.
Thank you.
As I don't see any questions from the audience, I could put one by myself. Okay. You promised so much. When is this going to fly, really?
When is this going to...
To fly, really? When does the business start? Everybody is researching and proposing all kinds of things.
We would like it to start very soon, of course, but as I said, it would be theoretically easy to sell a machine or technology like this to anyone by promising huge savings or income. But on the other hand, the branch is very conservative. Big houses especially take years from prototyping to second prototyping to third and even fourth prototyping before releasing anything and going into series. So we will have to just be patient.
So you maybe answered also my last question, which is, this technology enables totally new types of machines. You still showed us old-fashioned machines equipped with new technology. When do we see totally different machines?
Yeah, well, I don't know. Maybe the needs of people and companies are already fulfilled by these old machines, and we have so far concentrated in improving them. But it's true that, for example, this grid connection here is one thing that could potentially reduce the costs quite significantly, and that way maybe enable to use a machine in places where it hasn't been possible so far. But that remains to be seen.
Okay, thank you very much.
Thank you.
Thank you. And as one final word, I will be available at our company stand upstairs, and you can come there and see some of our products in real life.
Okay, and the program will continue in 8 minutes in different places. This is one of the places. Please find your next place where to go. And please remember that we have 25 exhibitors here, so visit the stands. Thank you.